Hello, everyone, and welcome back. I hope you're feeling refreshed and ready to dive into Module 2, Scientific Research and Ethics. Now, this is technically Chapter 3 in the Open Psych textbook, but I like discussing this before diving into the psychological models in more depth. We'll be exploring the fascinating ways that psychologists study the mind and behavior. Now, in this module, we'll uncover some basic methods that guide how scientific research helps us to separate fact from fiction, and why that's so important. But before we jump into today's topic, let's take a moment to reflect on Module 1. Psychology is often divided into the ABCs, affect, behavior, and cognition, which focuses on feelings, behavior, cognition, affect, or none of the above. The correct answer is C, affect. Affect refers to our emotions or feelings, an essential part of understanding human psychology. In Module 1, we discuss strategies for effective studying. Which of the following is a research-backed method for improving memory retention? A, rewriting notes repeatedly. B, using active recall. C, highlighting key passages in the text. Or D, skimming material multiple times. The answer is B, using active recall. Testing yourself on the material rather than just rereading it is one of the best ways to retain information. All right, nice work. And don't worry if you didn't get those questions right, you can always revisit the earlier lectures to brush up. So as we move into Module 2, I want you to think about this. Psychology is a science, but what makes it scientific? How do we move from abstract ideas to testable, reliable knowledge? Today, we'll start by looking at the risks of pseudoscience, when ideas might seem scientific, but lack the rigor to back them up. We'll then look at how to operationalize psychological concepts. We'll take a look at populations and samples, and how we measure data over time before we conclude. What if I told you I could understand deep truths about your personality, intelligence, and future just by measuring the shape of your head? Sounds intriguing, doesn't it? Well, that's exactly what the proponents of phrenology believed. Now, phrenology was a pseudoscience that gained popularity in the 1800s. It was based on the idea that the shape and size of bumps on your skull could reveal your character traits and mental abilities. Now, imagine someone running their hands over your head or saying, oh, right, this bump means that you were a born leader, or this bump suggests that you are very bad at math. Sounds fascinating, but it lacked one critical thing: scientific rigor. Here's why phrenology failed as a legitimate science. It had faulty assumptions. They believed that different areas of the brain controlled specific traits and that these areas directly shaped the skull's surface. Modern neuroscience has disproved this idea. It brought in bias and subjectivity. Assessments often reflected the biases of the practitioner. For example, phrenologists might find traits that aligned with social stereotypes of the time. And finally, there was no empirical evidence to support phrenology. Phrenologists didn't have reliable data to support their claims. Their conclusions were based on anecdotes and subjective observations, not systematic experiments. You might wonder why we're discussing phrenology now, if it's clearly outdated. But the lesson here is critical. Pseudoscience can mislead. It often presents itself as scientific, using technical language or appealing ideas, but it lacks the rigorous methods that make true science reliable. And it can have harmful consequences. For example, phrenology was sometimes used to justify discriminatory practices, reinforcing harmful stereotypes under the guise of science. And as you can see in this image, taking tapeworms to help get rid of your fat is probably not the healthiest idea. The failure of phrenology and other pseudosciences reminds us why systematic observation, experimentation, and reliable data analysis are essential in psychology. Here's a reflection. Have you encountered something that seemed scientific but lacked solid evidence? What caused you to be skeptical? Or why were you convinced? Take a moment to reflect on this. As we explore the scientific method in psychology, you'll gain tools to distinguish credible research from pseudoscience. So now that we've seen an example of pseudoscience, let's move to the heart of today's lecture. How do we approach reliable research? Psychology deals with concepts that are often complex and abstract. How do we approach ideas like love or happiness in a scientific way? The first step lies in operationalization. How would you study something as abstract as love? Imagine this: you're a researcher and you're tasked with measuring love. Can you scoop it out of someone's heart and weigh it? Maybe you could give someone a love breathalyzer to analyze how much love is in each exhale. Can you bottle it up? Can you translate the concept of love into a bunch of binary ones and zeros? This gets pretty tricky, but it highlights a big challenge in psychology. How do we scientifically study concepts that we can't directly observe or measure, like love, happiness, or stress? Operationalization is the process of taking an abstract concept, a conceptual variable, and transforming it into something concrete, measurable, or manipulatable. It's how we turn ideas into testable data. We need to define a concept first. Clearly describe what the variable means in the context of what you're studying. For example, what do you mean by love? Is it a feeling of ecstasy? Is it a measure of attachment to someone else? Is it a demonstration? Something that you can see through actions like a hug? Next, you want to develop a way to measure or manipulate this variable. Create a method for assessing or influencing the variable in a reliable and valid way, like counting the number of hugs that a person gives in one day. That might not exactly be some way to study love, but it is a way to operationalize it. Let's take a look at some examples about how we might operationalize certain abstract concepts, starting with our love example. One way that you could measure it could potentially be a self-report scale where participants rate their feelings for a partner on a scale from 1 to 10. It could be manipulated by showing participants romantic movies that try to evoke feelings of love. With stress, you could measure it by checking heart rate or potentially cortisol levels. It could be manipulated by giving participants a challenging math task under time pressure. What about attraction? Well, attraction can be measured, again, by asking participants to rate the attractiveness of a photo, maybe on a scale from 1 to 10. It could be manipulated by having participants interact with someone with or without makeup on. So why does this matter? Operationalization ensures that research is reliable. Different researchers using the same definition should be able to get similar results. It also improves validity. The method should accurately measure what it is you're claiming to measure. And finally, it helps research to be replicable. Other researchers should be able to repeat the study and confirm the findings. For example, if we define stress by heart rate, other researchers should be able to measure heart rate in their studies and then reach similar conclusions. Let's do another attention check. Which of the following is the best example of operationalizing the concept of happiness? A, defining happiness as a general feeling of satisfaction with life. B, asking participants to rate their happiness on a scale from 1 to 10. C, telling participants to think about the happiest moment of their lives. Or D, measuring participants' daily routines to infer their level of happiness. The correct answer is B. Operationalization involves creating a concrete, measurable way to assess an abstract concept, such as using a rating scale to quantify happiness. Now that we've explored how to measure abstract concepts, let's turn to the people involved in research. How do we decide who to study? That's where populations and samples come in. Imagine you're conducting a study on how social media affects CU Boulder students' mental health. Well, who are you studying? Your immediate thought might be all of CU Boulder, and that's your population, the entire group that you're interested in. But here's the thing. Studying every student in the university would be incredibly challenging, if not impossible. That's where a sample comes in. A smaller, manageable group selected from your population to represent it in your study. Samples are crucial because they let us make inferences about the larger population. But for those inferences to be valid, the sample needs to be representative. It should reflect the diversity and characteristics of the whole population. For example, if you're studying CU Boulder students' social media use, but only include students from the psychology department, your findings might not generalize to students in engineering. A more representative sample might include students from all of the different departments across the entire campus. I also want to clear up a bit of common confusion. Random sampling is how we select participants from a population. Every individual should have an equal chance of being included to reduce bias and ensure representativeness. Random assignment is what happens after participants are selected. It's how we place them into different groups or conditions in an experiment, ensuring that each group starts out equal. Random sampling would be choosing 500 students from across the entire CU Boulder student body. Random assignment would be randomly assigning those students to either a high social media or low social media use case within an experiment. Imagine you're studying how college students cope with stress. Which of these samples do you think is most representative? A, 100 psychology students from a single university. B, 500 students randomly selected from universities across the country. Or C, 50 students chosen based on who replies fastest to an email request. The answer would be B, 500 students randomly selected from universities across the country. Using a biased or unrepresentative sample can lead to skewed results. For example, if you only study students from elite universities, your findings might not be able to apply to students from community colleges or trade schools. If your sample lacks diversity, your findings might not generalize to the many different cultures that exist in your population. Next, we'll explore 2 ways psychologists study changes over time. Human behavior is dynamic. It changes over time. To understand these changes, psychologists use 2 key approaches: longitudinal studies and cross-sectional studies. Each method offers unique insights into how people grow, develop, and respond to different experiences. Longitudinal studies involve following the same group of participants over an extended period, collecting data at multiple points in time. This allows researchers to observe how variables change within individuals. For example, let's say researchers want to study the long-term effects of childhood media exposure on aggression. In a longitudinal design, they might follow a group of children from age 8 to age 18, measuring their media habits and aggressive behaviors every 2 years. Some strengths of this approach include that it tracks development. It reveals how individuals change over time. It establishes temporal precedence. By observing events as they unfold, researchers can determine which variables come first, which is critical for identifying causal relationships. Some limitations include that it's time-consuming and expensive. Tracking participants over years or decades requires significant resources. And there's often high attrition, which is when participants may drop out of a study, which can lead to biased results if the dropouts differ systematically from those who remain. Cross-sectional studies, on the other hand, compare different groups at a single time point. Researchers collect data from various age groups or various populations and analyze differences between them. Imagine studying how children develop language skills. Instead of following one group for years, researchers could collect data from 2-year-olds, 4-year-olds, and 6-year-olds all at once, comparing their vocabulary sizes. Some strengths of this approach include that it's efficient. Cross-sectional studies are faster and less expensive than longitudinal studies. They also don't have attrition since data is collected at a single time point. Researchers don't lose participants over time. Some limitations of cross-sectional studies includes that there's no temporal precedence. It's harder to determine cause and effect because you're looking at different groups rather than tracking the same individuals. There also can be cohort effects. These are differences between groups that might reflect generational or cultural factors rather than actual developmental changes. So how do researchers decide which methods to use? It depends on the research question. If you want to understand changes over time, longitudinal studies might be ideal. But if you're looking for quicker insights into age-related trends, cross-sectional studies might be more practical. Take a moment to think about how you'd answer this. Imagine you're studying how people's preferences for music change as they age. Would you use a longitudinal study or a cross-sectional study, and why? Both methods have their strengths and limitations. So it's about matching the approach to the question. Today we explored the building blocks of psychological research, how we move from abstract ideas to testable science. Let's recap the highlights. The risks of pseudoscience showed us that phrenology can give us an important lesson, though it might not be related to the shapes of bumps on our heads. Just because something looks scientific doesn't mean that it is. Psychology requires rigorous, evidence-based methods to avoid the pitfalls of pseudoscience. We learned that operationalization helps take abstract concepts like love and happiness and turns them into something that can be measured. It allows us to define and measure these ideas in a scientific way, ensuring reliability, validity, and replicability. We talked about the difference between populations and samples, and we learned the importance of selecting representative samples from a population and how random sampling can reduce bias. We also distinguished this from random assignment, which ensures fairness in experimental conditions. Finally, we looked at how we measure data over time. Longitudinal studies track changes within individuals, while cross-sectional studies provide snapshots of differences between groups. Both methods have unique strengths and limitations. Let's do some review. Which of the following best describes operationalization? A, using anecdotes to explain a concept. B, turning an abstract idea into something measurable. C, selecting participants randomly for a study. Or D, manipulating a variable to prove a hypothesis. The correct answer is B. Operationalization involves defining and measuring abstract concepts in a scientific way. What is a key difference between longitudinal and cross-sectional studies? A, longitudinal studies track changes within individuals over time, while cross-sectional studies compare groups at a single time point. B, longitudinal studies are faster and less expensive than cross-sectional studies. C, cross-sectional studies are more effective at establishing temporal precedence. Or D, longitudinal studies avoid attrition issues that affect cross-sectional studies. The correct answer is A. Longitudinal studies follow the same participants over time, while cross-sectional studies compare different groups at one time. Psychology thrives on its ability to take things that are invisible, like our thoughts and emotions, and make them visible through rigorous research. The tools we discussed today are the foundation of that work. Take a moment to reflect on this. The ability to question, analyze, and evaluate evidence is one of the most powerful tools that you can have, not just in psychology, but in life. In our next lecture, we'll dive deeper into research methods, exploring how psychologists design experiments and interpret results. As always, thank you for joining me on this journey into the science of the mind. Stay curious, stay resilient, and above all, live life in flux. Flux out.